So, welcome everyone, and thank you, Tom, for taking time away from your busy summer harvesting and fermenting time. And so today we'll learn more from knowledgeable Tom and his amazing vegetable and farming business. So, thank you and welcome, Tom.
Thanks. Okay, so the slide is full screen.
Yes.
Okay, great. All right, thanks. So hi, everybody. I'm Tom Ruggieri. Rebecca Graff and I, we run Fair Share Farm. We're out in Northeast Clay County. So I'm going to spend, probably first 10, 15 minutes or so kind of giving background on the farm and kind of the importance of live culture food. So I'm only going to talk about vegetable fermentation today. You know, there's a lot of fermentation types from, grapes into wine, milk or into cheese, bean curd into tofu, meats. But we're just going to talk about vegetable fermentation. This is our farm. Like I said, we're out in Kearney. We're about 45 minutes north of Kansas City. There's Rebecca and I in our natural state out on the farm, planting some garlic there a couple years ago. And so I'm glad you joined us because as Wendell Berry says, if you eat, you're involved in agriculture. And I think that's important for everybody to realize the impact we have just by the choices we made in making the type of food we buy. And it's important to know where your food comes from. And this is about, in part, kind of taking control of your diet and of your food. So a couple years ago, we started a fermentation business. We had a CSA for 18 years, community supported agriculture. Last year was our last year for a CSA. And then this year we are having fermented vegetables be our main source of income. So here's just kind of some examples of what we raise. We raise a lot of, like 10 vegetables: cabbage, carrots, onions, beets, jalapeno, some things like that. And so we prepare a variety, about 10 different types of ferments, and they're seasonal. And so all these, for the most part, well, for all of them, over 95% of what's in the jar was raised on our farm. And these are live culture foods. So it's a way of looking at a farm kind of more like a winery or a dairy, really, in that we raise the vegetables, we process them on farm by fermenting, and they're a preserved product. And I'll talk about more all this as we go along. I just want to take a minute here before we start to do a land acknowledgement and just talk a little bit about the land that we're on. So Rebecca's family has owned this piece of land since the 1950s. So that red dot is where we are. This large kind of yellow area, it's called Section 69. So this part of the country is ancestral Osage Native American land. So the Osage lived in this area as far back as about 1,000 years ago, when Cahokia was a dominant city over by St. Louis. A lot of the settlements were down along the river. You can see right here, Little Osage Village, 1805. It was around that time that the United States started to kind of take over this part of the country with settlers and purchasing it from the Indians. Section 69 is an area that was purchased by Meriwether Lewis, kind of coordinated it. And this whole area, a lot of it upland where we are, there weren't a lot of settlements because there wasn't a lot of water, and it was mainly hunting grounds. So we're on ancestral hunting ground, and was stewarded by the Osage, and we're stewarding it now. Another, I think, important aspect of the land where we are is, most everybody knows, Missouri was admitted to the Union as a slave state in the 1820s. And our little township, 6 square miles, or 6 miles by 6 miles, there were over 400 enslaved African Americans, and that was just the law of the land out here. And there's a very good chance that slave worked our land, and we feel it's important to acknowledge that that's happened on our land, and that again, we're stewarding this land and hope to keep it free. So this is more of a geographic picture of where we are. Here's Watkins Mill, if you're familiar where that is. You can see here, this map shows the prairie, 1829. So there's like a tongue of land here. This is kind of the higher ground. It was probably burned by the Native Americans to keep it open as a grassland. And there's woods here that go down to these creeks. So our farm is kind of on the edge of the prairie, as they say. This pink area is the land that we rent from Rebecca's family. And actually, we're looking to kind of try and farm this land again like this, when it was an oak savanna. And that's a whole nother story, but it's a matter of listening to the land and going back and trying to farm it or have an agricultural business and have it reflect the nature of the land. So here's a drone picture of the farm. Here's our house. This is an old tobacco barn we've been refurbishing and for the past 20 years. This green roof here, this is where our fermenting kitchen is. We've got an equipment barn. It's not on this drone picture, but we have a 20 kW solar panel system over here, a greenhouse. And then we've recontoured our land to have over 7,000 linear feet of berms and swales that helps us hold all the water that falls on the land and have it not just rush off and create erosion. So kind of the point of this is that the land's a living thing. And in talking about live culture and fermented vegetables, it's really it's just important to make that connection. That's what we've been trying to do for the past 20 years. It's like, how can we really do something out here that is connected to the land and to our bodies and to the community and to the health of the landscape. So one thing we, realized, which I hope everybody does, that you are what you eat. And since you are what your plants eat. And so feeding the soil is really one of the most important things that we do on our farm. Like I said, it's important that we feed our soil the same type of healthy things that we want to eat. The soil is really like the guts of the plant. It has its own microbiome, just as we have our human microbiome. And organic agriculture, it's important to know that it's indivisible. The whole idea is the health of the soils, the plants, the animals, the humans, the planets. We're all connected. We're all, it's like we're in an ocean. You can't really get out of it. It's all one thing. And this indivisible nature is something that we focus on, and we've kind of felt and understood even more as we've been doing this type of farming for the past 20 years. So to put this into perspective in the soil, over the past 10 to 15 years, a lot more science has been done to understand our connection with life in the soil and in our bodies. I know people that were basically soil scientists, agronomists, and they went to college and they didn't even study soil microbiology. So the soil was only about the chemicals in it. Whereas what's important to know is that it's really the life in the soil is where everything comes from. And you can see here an example. This is a root hair on a plant. And what happens right there at the root hair, at this kind of interface between the soil and the plant, is really important, and it's where a lot of the action happens. So there's this biofilm, and a lot of the bacteria, same type of bacteria that live in our body, populate this what's called plant exudates, kind of a biofilm, and they're bringing the nutrients out of the soil into this interface. And at the same time, you can see over here with a plant or a tree, part of it's up here where it's light and it's collecting solar energy and converting into sugars. And then they bring it down into this dark area underground. And that's where these sugars are kind of swapped out for other metabolites from the bacteria. And the same thing happens with these fungal hyphae. So this fungal hyphae can stretch for yards and yards. So the effect, in effect, this tree is really pulling from way, way over here, not just from right around the root hairs. And I think that's an important thing to realize, that plants are really literally plugged into the soil. There's all sorts of connections going on. And if they're not plugged in, they're not thriving and they're not as healthy. And so now let's look at our, what's going on inside our body, the human microbiome. So you can see it's the same type of thing. You got this human animal tissue, which is the inside of our colon. And then you have this biofilm, and that's where all these bacteria live. And they, as you know, there's probiotic microbes, ones that are good for you that naturally live in our digestive system. And then there's ones that aren't so good, that we want the good ones to basically combat and keep us healthy. And over on this side of this diagram, you can see if you don't have a healthy microbiome and it deteriorates, then you're subject to, basically leakage. You have all sorts of disruptions that can happen to you. And, you can treat those symptoms, or you can try to reach this, what's supposed to be our homeostasis condition. And that's part of what having live culture in your diet can help with. Rebecca and I were pretty healthy, doing what we've been doing for all this time. And we feel that once we started making the ferments, and they were just a regular part of our diet, that we're even healthier. The soil, the life in our soil literally runs through our bodies. So we're, talking about being connected to the land, it sounds kind of, like, what's that really mean? And we realize what it really means is that you're actually connected to the land. The life in the soil is run through your body. So we'll talk about the human microbiome a little bit more now. I think everybody kind of understands our digestive tracts. You come in here through the stomach, into the small intestines, and then into the large intestines or the colon. And you can see here that lactobacillus is a bacteria that can make it through all of these stages. The stomach acids are pretty strong. Lactobacillus and some other probiotics can make it through. Lactobacillus lives in the small intestines. Lactobacillus lives in the large intestine. And lactobacillus is what is the main bacteria responsible for the fermenting of vegetables. Also, I was listening to a podcast on Radiolab one time called Guts, and they talked about how our digestive system, is really just a passageway that runs through us. So really our inside is really our outside. Anything within this digestive tract, it's not going to be up against, your kidney or your internal organs. This is all external really to our body. And I think it's important to know that. So really we haven't, and what comes out basically is soil. So we have to realize just how connected we are. It's in our natural state to have microorganisms from the soil where we live running through our body. And if you're missing out on that, then, it really affects the idea of dieting, because you have to have your whole system operating properly in the first place. Now, these bacteria, they're some of the first forms of life on Earth. They're prokaryotes, which means they don't have a nucleus. Most bacteria, like lactobacillus, they kind of do one thing, like convert sugars, starches into lactic acid and replicate. That's just what they do. And these little replicating machines of life, they're some of the first ways that life was formed on Earth. So we formed around them, and we're really connected to the beginnings of life every day. And the whole point is we grew up together. That's why we're acclimated together, is that we both get something out of it. It's a co-evolved symbiotic relationship. And that's what goes on in the soil with that diagram I showed. It's what goes on in our body with that diagram I showed. And it basically goes on everywhere. And then this is the alternative. This is what 90% of humans are eating. You're what your plants eat. This is, synthetic nitrogen, synthetic chemicals. As much as what gets sprayed on your food, to me, it's what we're feeding our plants. It's a synthetic system. That cucumber that you buy that's raised conventionally, it's raised in an artificial system. There's artificial components in the food chain, so it's not even all natural. And so you can't even compare it with an organic cucumber, because like I say there, it's like comparing apples and synthetic chemicals. They are two completely different systems. So the idea that they're equivalent is really nonsense. And I think just through the health of humans and I think it really affects our health a lot, and the environment. If that's all you're doing is pouring this on the ground, it's diminishing the land at the same time. So now, let's see here. Yeah, we got plenty of time. It's just kind of a warm up as to the importance of the ingredients and your impact on the environment. And so now I'm going to talk about how you turn these vegetables into food and how you ferment them. So what we do is called farm to ferment, or like to say farms that ferment. There aren't a lot of, it's kind of uncommon what we're doing, but what we're doing is very common, in that we're an example of a traditional agricultural craft of raising a product, preserving it on farm by fermentation, and having it manifest the quality and life of the farm soil. So if you think of a winery, they raise grapes, they do all the winemaking at the vineyard, and you talk about the terroir of the wine, and that reflects what the soil that the grapes were grown in. Well, it's the exact same thing with a ferment. With ours, over 95% of the ingredients were raised on our farm. So our ferments are unique. It's like we have our own vintage. A lot of the recipes we didn't really come up with, they're traditional, but our Missouri soil that we've been building for 20 years is more of a factor in the flavor of our ferments than the recipe, way more. And I just think it's important to know that. And you have a garden and you're growing all the vegetables you need to make a certain ferment, and you've been caring for that garden for a lot of years, your ferments are going to reflect the quality of your soil and the life in your soil. So it's a way for you to get connected to your land also. So what is fermentation? So it's a desirable process of biochemical modification. So biochemistry, I don't know how many taken biochemistry, but there are just so many processes going on in a biological system. You can have the Krebs cycle, or all these different things where all these different products are being created as something is being digested, and then it feeds another system, and you have all these different pathways, and energy is being extracted. So it's a desirable biochemical modification that if you know what bacteria works and what it does, you can kind of focus in on that and have that be the main process. So it's purposely carried out. And in case of all these, it changes the flavor profile of the food. So, you could mix up all the ingredients for kimchi, and eat it, and it might be perfectly good, might be a little salty, but by the time the fermentation is done, it's a different thing. And in many cases, it's a more desirable thing. And it's also a step of food preservation. So you're preserving food by acidification. Most pickles these days that people make at home, you use vinegar. So vinegar is acetic acid, and that's the same type of thing. It's an acidification. You get the pH below 4.6. So when you're fermenting, you have a pH strip or some other way of measuring it. 4.6 at least is if you're going to sell it. You have to be below that for it to be a food that's been safely acidified. So with lactic acid bacteria fermentation, the bacteria create lactic acid instead of acetic acid, and it does the same thing. It lowers the pH and it preserves the food. But lactic acid tends to be a little less sharp, a little bit mellower, and it maintains a live culture. Here's a little bit about the history of fermentation. This slide's a little busy and it has everything on it. Basically wine and bread were kind of some of the earliest forms of fermenting that were known. You can see here, Neolithic times, and they started doing cheeses. They say once we had dairy, it's like, you put milk in a calf's stomach, which is, would have been a bag or a container that would have been used, and you go down the road and it jiggles around. All of a sudden, you have solid curds in there. And so things like that were probably learned just because they happen naturally. Now, this doesn't show it. They're saying here a worldwide 500 BC pickles and preservation of food. I have some other documents that basically have said closer to 3000 BC, a lot of vegetable fermentation was going on. Cucumber pickles, Egyptians fermented cucumbers into pickles. So that's pretty well known to have happened. I read one place that said that, kimchi, at least fermented vegetables, say in Korea, happened around that same time. And what was done was vegetables were put in seawater. So seawater has a salinity of about 3.5% salt. Like when we do sauerkraut, we use 2% salt. So the seawater is naturally around the salinity that you want to help the lactobacillus bacteria predominate and preserve the vegetables. So like with all these things, they were kind of, we don't know how they were really learned over time, but we can see how they might be some natural steps. So we're talking, what I'm talking about is, probably 4,000 years, 5,000 years old, and which is pretty incredible. So then in the 1860s, Louis Pasteur came up with his germ theory. So we had all those years, almost 5,000 years, and it's only within the last 150 years that we've even known really what was going on. We're looking at making raw vinegars on the farm, converting elderberries to wine and then to vinegar. And so I got a lot of these older books on vinegar production, see how it's been done historically. And I have one book, it's from the 1860s, and they don't even talk about bacteria in it. I mean, they didn't even know. So I have like a relatively modern book, and the science hadn't been determined yet. But people have been doing it for all that time because it was more art and craft than science at that point. So what is lactic acid fermentation? So like I said, when salt's added to the vegetables, lactic acid bacteria are able to predominate and convert carbohydrates to lactic acid. So they can handle the salt, these lactic acid bacteria. They and then they can start to predominate. And as they predominate, they produce acid, which lowers the pH, which kills other bacteria, certainly any pathogens. And so that in the end, they're pretty much the only thing. Different strains of lactic acid bacteria are what remain. And so it's a way for us to control the fermentation. And in doing that, the lactic acid sours and preserves the vegetables. So it's really, that simple. So this is kind of what it looks like. So lactic acid bacteria, there's different types, there's a lot of different strains, but essentially what happens is you have glucose here, some type of starch or into something that's been broken down into simpler compounds like glucose. And the glucose is then broken down through biochemical pathways into pyruvate, which in turn is converted to lactic acid. And it looks here, this bacteriocin, this is actually kind of like antibiotic that the lactic acid bacteria will produce that also helps it to kind of fend off other bacteria and predominate the system. So you can see you have glucose coming in and lactic acid coming out. So it's really a breakdown product of by lactic acid bacteria. And you can see here, this is really kind of what it looks like. It's a circle or kind of elliptic bacteria. So like there's, DNA strands in here that you don't see, but there's no like nucleus. There's just the strands in here. And as they grow, they'll divide and replicate. So it's, like I said, it's a simple form of life. So now let's get into making it. So I already kind of talked about the soil and how important it is, and feeding the soil and making sure that the substrate you start in is healthy and alive. So if you want to, I know not everybody has a garden, but there are good organic farmers markets out there, like Brookside, where you can get local produce. And so you can kind of be aware of, from seed to jar, where your product comes from. So like I said, we raise everything that goes into our ferments. These are onions that we start, you can see here, back in February. We're actually just harvested these last week. It allows you to pick the varieties that you want to use. So if you want to do your own ferments, you can kind of think ahead. It's like, okay, well, what goes into it? What can I grow? What varieties do I want? So you plant stuff, it grows, and then you harvest it. And that's kind of the fun part, is getting to harvest things. So we have a lot of cucumbers this year, which feel pretty good about. And so different crops require different kind of treatment. So if you're going to be fermenting, you want to have fresh ingredients. You can store ingredients, but you want to get ingredients when they're as fresh as can be. So things like cucumbers, you really don't want to hold them very long because they don't hold that well. Like we hold ours at 50 degrees and they'll hold for 4 or 5 days. If we can get the timing right, we'll ferment them like the same day. So you want to make sure that you keep your vegetables fresh. We also harvest a lot of cabbage and Napa and carrots and things like that. Things like those vegetables you can store. Carrots will store. They'll actually get a little bit sweeter when you store them. Beets are the same way. Cabbages can store a long time. So you have to know the vegetable you're dealing with to handle it properly. And then you prepare the ingredients. So like here, we don't use this anymore, but we have drum shredders. So we would make cabbage or sauerkraut using this piece of equipment. I think a lot of people have probably seen in the old days, there's like a big mandolin that people would use to slice cabbage, and they were slicing cabbage to make sauerkraut. So the preparing the ingredients is, I haven't not really showing a lot here because really it's just a bunch of chopping. Making a ferment is really pretty simple in that it's no different than any other recipe you might have in your kitchen. You're going to chop stuff, you're going to grate stuff, you know, however you want for your recipe. So like this is kimchi. And so kimchi is essentially Napa cabbage. When we do ours, it's about 80% Napa cabbage and about 20% root vegetables. And it can be a mix of root vegetables. And then we mix that with salt, 2% by weight. And then we make a paste of paprika and chopped garlic and ginger. So you can see, you know, like we like to have bigger chunks for the white part of the Napa. You know, we're cutting these radishes here. They're small radishes and the little half moons. You know, the garlic and ginger is all in the paste, so you can barely see that. The root vegetables, we might have shredded the carrots, or you can leave them bigger. So you can read up on whatever recipe you want and really kind of prepare it to suit your taste. You know, with the cabbage, everything was kind of shredded and all the same size. Whereas with something like the kimchi, you can get a little more creative and, you know, make it. Traditional kimchi actually is, you know, you pretty much just like quarter or half or even leave a Napa cabbage whole, and you just kind of stuff it with the other ingredients and then let it ferment. So there's lots of ways to do all of this. And then you add salt. So there's a lot of literature out there that says that 2% salt is really kind of an optimum amount of salt for most vegetable ferments, 2% by weight. So if you have 10 pounds of cabbage that you want to ferment, so 10 pounds times 0.02 is 0.2 pounds. So for every 10 pounds of cabbage, you'd use 0.2 pounds of salt, which is like 3 ounces. And for like a quart jar, which is 1.5 pounds to 2 pounds, about a tablespoon of sugar or of salt is typically what you use. So that part makes it pretty simple. Now, traditional kimchi, it's my understanding they salted it maybe 15% and then they rinsed it. So there are a lot of different ways to do things traditionally. We have found in trying to do this commercially to use less salt and not have a lot of waste brine, that just 2% works the best. Now, the salt you want to use, I would just recommend like an ancient sea salt. We use Redmond real salt. It works really well. It has a lot of micronutrients in it. You don't want to use table salt. Table salt might have anti-caking agents in it, and that can make things kind of funky. Anything that's been kind of over refined, you don't want to use. I guess pickling salt can be okay, but even that's refined. We went to the ancient sea salt, even though it's a little more expensive, because we started to read how modern sea salt has microplastics in it. So we have a way of staying away from that, and so we do. And so I would recommend using the real salt for your ferments. And here's a little table about the importance of the salt. So the more salt you use, as it says, it makes things crisper and a little less likely to spoil. Obviously, things that are really salty, you know, meats and all sorts of things are preserved in salt. So salt has just by itself real food preservation power. I don't know how much slower it really makes the fermenting process, but if you use less salt, it's much more likely that the product can spoil. It might, its texture will be softer. We see that without a doubt. You know, pickles are a good example of that. If it's not salty enough, your pickles aren't going to be crisp. And so you don't want that. You can use too much salt and actually inhibit fermentation. I'm not sure how much that is, but it would seem like things would be really, really salty when it comes to vegetables if you reach that point. But you don't want to use too much salt. And like I said, you don't want to use too little salt because it helps the lactobacillus get a jump start on the other bacteria. And as it said here, bad bacteria will overtake the good bacteria and the fermentation will spoil. If things spoil, they get really soft. You get a odor that, probably isn't very good. You can have a lot of mold forming on the top, pink mold and different things like that. So there's ways you can fail pretty easily in fermenting, but there's ways you can succeed pretty easily too. And that's what I'm trying to get across here. This isn't a demonstration of how to make sauerkraut. It's more a talk about what are the important and the key factors in fermenting vegetables. So the ingredients, how they're sourced. You don't want to get something that's just pumped full of, ammonium nitrate crystals. You want something that was raised in a live soil. And you want to make sure you cut things properly the way you want. And you want to make sure you have the right salt content. So here's some pickles I'd be making. So with the pickles, we've learned over time that for us about a 4% salt solution works. So with the other vegetables, like if I go back here to this kimchi, you can see it's got a liquid forming here and it's starting to weep a liquid. I didn't add any liquid to this. The salt brings the liquid out of the vegetables. You don't have to pound cabbage with a baseball bat. People have done that, traditionally to get the juices to flow in sauerkraut. But we find if you just put 2% salt and you let it sit a while, it'll weep its own liquid. And then as you push it all down in your container, the liquid will rise above the level of the solids. And then you have what you want. So that works with most stuff, but with cucumbers, whole cucumbers, it doesn't work there. So you make a 4% solution, brine solution, and you can look up online the formula for that, depending on how much you might want to make. We do ours in 7-gallon buckets, kind of 30 pounds at a time. And so the 7-gallon, a 5-gallon bucket of brine requires 26 ounces of salt. And then we also add a little bit of calcium chloride, pickle crisp. It's something you can look into too. You only usually need a small amount to help with the crisping. It's not shown in here, but we put grape leaves over these also. Grape leaves have tannins in them and they're supposed to help keep things crisp. With cucumbers, you can see the ends of these are kind of nubbed off, as we say, or we nub them. There's an enzyme that exists on the flower end of cucumbers that can make them soft when they're fermenting. So these are all things where the ferments, a lot of ferments are pretty much the same, and then some require kind of a different approach. This is just an old recipe. It's probably from the 1880s or so. Sauerkraut's been made for a long time. And make it these, you would make it in a barrel in the old days. You'd get a whole lot of them, and you'd shred it, and then you'd layer coarse salt in it, and then cabbage, and then coarse salt, and you'd keep pressing down here with a heavy pestle, they're saying. So that's where the pounding would come in until the juice floats on the surface. The same thing we do. Then you add more. Some people put, coriander or juniper, caraway seed, things like that to flavor it. So there's different things you can do there. Place it in a dry cellar. So I'll show you as we're moving along here. You want to be at about 65 to 70 degrees optimally for a ferment to kind of start and proceed to completion kind of without having to stop and start. And, saying here, put it in a dry cellar, cover it with a cloth, and put a plank on the sauerkraut and weigh it down with a heavy weight. So I'll show you that too with the containers. It's really important that you set things up here the way they said back then. I was never sure what this meant with this. They talk about taking off the liquid and washing it and covering it again and putting it weights back on. I've seen this in some other recipes, but that's not something you recommend. I recommend you just let the liquid be rendered from the vegetables and then just leave it in there. Let stand a month and it'll be ready for use. So that's true too. We ferment our sauerkraut at 70 degrees for about 21 days. And then it's pretty much still at that point. And back then they ate it with meat, just like we do. I think it's an important thing about ferments too. You're eating meat, and potatoes. It's nice to have something that's a little more alive, a little more roughage, just to balance different meals. So ferments are good from that way. They add some diversity and balance to your diet. So this is a typical container. Again, you can go online and search for fermentation vessel and a lot of different things will come up. So this is kind of a traditional. So this is you can buy modern crocks and modern weights like this, Ohio stoneware. You can just look them up. At first we were gonna do all our ferments in these containers, but we do a lot. We do thousands, basically tons a year of ferments, and these containers just wouldn't be able to, they'd be too large to be able to do that. We use food grade 7-gallon buckets, but this is perfect for home use. Again, you can see the cabbage there has rendered a liquid, and these weights are put on there and they hold the solids underneath the liquid. That's what you want to do. And this is 2 gallons, so you can make yourself a decent batch. When you do this, it's important to put, say, a towel over this and then a plate, and check it regularly. So if air gets in here, you can get mold forming on it. If you don't watch it on a regular basis and it's dry out, this liquid can actually evaporate, and then you're just down to the solids, and that's not good. That's like kind of the worst thing, and probably one of the things that people end up with the most with their problems is they don't maintain this liquid. So if you have like a 2% brine and this starts to dry out, you can just pour more 2% brine in here. So keep your vegetables covered with the ferment liquid. Here's another picture of a container you can use to ferment. So these crocks, I guess they've been around for a while, but this is like an airlock. So there's a little moat around the top of the crock that the lid fits in, and then you put water in here. So gas, as it's generated in here, kind of bubbles through the water and out. It helps keep the aroma of the ferments a little more in check if you're doing this in your house. It helps keep the evaporation from happening as much. And you can see here, here's your pickles. here are these weights, and then you have all this liquid over the top. And so this is kind of ideal. And there's a lot of things that you can get for jars. I've never actually seen these. I forget where I got this picture, maybe Pinterest or something, but it's like perfect. It's a little weight. I'm assuming this is ceramic and not metal. You know, you don't want to use anything metal because the salt content and the pH can just eat it away. You really don't want anything that's like a stone that's reactive. You know, you could use a piece of granite, something like that as a weight, but you don't want to use limestone because acid will just dissolve it. You know, this looks like a rusty piece of metal, but you know, you certainly don't want to use that. Another thing you can use, depending on the size of your container, is like a freezer bag filled with brine. You know, that'll add some weight, and you can put a plate. You know, if this was a bucket, you could put a plate over it and then put the bag on that. So there's lots of different ways to weigh stuff down. There are also a lot of containers these days that you can buy. This is a one-way waterless airlock valve. Oop. So you can see, same thing. Here's what you're fermenting. Here's your weight. Here's the liquid above it. And then this is just like an airlock. And so it'll just let the gas come out so this doesn't build up too much pressure. You know, luckily the ferments, vegetables don't necessarily cause as much pressure as, say, a wine would if you were making a wine in a container. So some people might just have a regular jar with a lid, and if they have something to weigh this down, they'll just kind of crack the lid every day and let the gases out. So this is a way to do it in a small batch. Like I said, you can go online. There are lots of things that you can buy, but hopefully between all these things, you know, an old-fashioned crock, one of these really nice ones, you know, jars with weights that you may even have kind of figured out yourself. You know, you can kind of have a plunger in there. You could have that and then put a little plastic, you know, medicine cup in here and close the lid, and it would push it down. Or something like this that kind of burps on its own. So another problem people have, or things that kind of scare them in doing the fermenting, is mold. So there's lots of different types of mold. This is like a white mold. This is called COM. It's perfectly fine to simply scrape off and keep going. You don't want to get like a gray mold or a pink mold. If you see a pink mold, chances are your ferment is kind of going downhill and that it's too warm. But with this, you know, if you're making sauerkraut in one of these containers, you know, you want to look in it every 3-4 days. And if there's mold forming, you may not have enough water in your rim, and you can just get a little strainer and skim it off. You just don't want the liquid to be all the way down to the surface of the solid and have a mold form there, because when that happens, then the mold hyphae can kind of go down more into the solids, and it can ruin your ferment. So what's the best temperature? So we've dealt with that a lot. Pretty much like they say here, 65 to 70 is the sweet spot. We try and stay at 70 degrees. We don't want to go over 70 degrees. It does start to get too warm, and you can get other things kind of forming on the surface. So that's what I'd recommend. So if you have a nice air-conditioned room or house, whatever room, basically the ferments want to be as comfortable as a human would be. So somewhere between 60 and 70. You get below 60 and fermentation will still happen, but much slower. We have that problem in our kitchen. We're in an old barn, and we're able to keep it air conditioned and dry pretty well in the summer. Like right now it's fine, but it's harder to heat in the winter, and our ferments get a little cooler. So they don't go bad, but they take longer to ferment. And then how long? So how long do you ferment? So like the one old recipe there showed with sauerkraut, you know, you're basically going to go a month. What happens is there's different stages. So these are all more or less lactobacillus bacteria that you see here at these different stages. So for the first few days, there's kind of a strain that'll kind of kick in and get things started. And then after a few days, there's another one, the plantarum, which like they say here is the main fermentation. And you can see the lactic acid concentration just rises as you go. So somewhere around here, around whatever that is, 0.3, that's where this this bacteria can't live anymore. So it dies off because the lactic acid level continues to rise. What we do when we keep track of our ferments is we check the pH regularly. And like I said, the pH for acidified food to be sold need a pH of 4.6 or less. And when we're done with our fermentations, usually we're closer to 3.6. So things are nice and sour, they're nice and safe. They're actually 10 times more acidic than what's considered a safe level. And yeah, they provide for a really flavorful ferment. So this is kind of, maybe sauerkraut follows this. The fermentation time, pickles, if you put them in a 4% brine, you probably don't want to pickle them for ferment them much more than 4 or 5 days, maybe 6. I don't know. A little bit cooler temperature wouldn't hurt for them, but you don't want them to go too long because then they'll get soft. Our kimchis, we usually ferment them for about 10 days or so. They seem to ferment quicker than the cabbage. So some of it you can look up, and there's probably contact information here. If anybody has a question, you can contact me and I can help you out there. But that's so that's the time. So we went over the ingredients, the importance of how you source and grow your ingredients, and preparing the vegetables, how much salt you use, how you arrange your fermenting vessel, what temperature you keep it at, and how long you ferment. So that's really the key steps to fermenting vegetables. It's important to kind of understand that before you get started. And then when you're done, you jar it and store it. So historically, refrigeration didn't really exist. You know, I think a lot of people, know, like in Korea, kimchi pots are buried in the ground. You know, a lot of that's for keep a more consistent temperature. So we're able to maintain a pretty good quality control, and you will be too, if you're able to keep your fermenting temperature consistent and the state of your fermenting vessel proper. And then when the ferment is complete, you can bottle or jar what you have and keep it at in your fridge, 34 to 40 degrees. And it's a preserved food at that point. It should last indefinitely as long as you keep it cool enough. And, don't let too much air in there, and don't eat a little bit and never go back to it. It's a preserved food, but it's meant to be eaten. So, that's the way we look at it. We're not doing this to prepare for the end of the world. We're doing this to preserve the food that we're raising today so we can eat it tomorrow and the next day, or enjoy it at Christmas time or later in the year in the winter. So that's kind of the goal. And some of the different ways to enjoy your ferments, just as a side dish, we have a little 4-jar caddy that we just leave in the fridge with 4 pint jars of ferments, and just bring it out at a meal, and you can take your pick as to what you want. It's great to top a dish, if you're It keeps it pretty much live culture. You know, you can treat it as a condiment. A lot of the ferments, like we make curtido, it's kind of like sauerkraut with, it's a traditional El Salvadoran recipe, carrot, onion, garlic, and oregano. It's just perfect on a sandwich, in a taco, in a burrito, on a cracker, kind of anything. You know, sauerkraut is good just on grilled cheese, and you know, you put it in with you cook some potatoes and mix it right in with it. You know, it's like cold cannon. It's like a dish where you might have cabbage and potatoes cooked together, and it makes for an instant kind of interesting dish. And the pickles are nice because, you know, eat a pickle or two a day and you're kind of getting your daily dose of probiotics, and without even having to do much. And if you make them, and if you make your own pickles, then it's that much better. So I think that is the last slide. I'm gonna check the chat here.
Well, let me see. There are a lot of messages. So there is one technical one, if I may read it. And it says, is the yeast contamination an issue since we will survive acid salt combo?
There's not really a yeast issue with the fermented vegetables. Lactobacillus kind of overtakes the yeast. You know, it's not like a SCOBY forms or anything like that. The vegetables are different than like a tea or something that has sugar in it, where the, you know, straight sugars, where the yeast take over. And the yeast is a little more aerobic situation too. So you can get some yeast forming on top, but it shouldn't affect the vegetable fermentation because of the salt.
Another question, is there a reason not to start using lactate?
Reason not to start using lactate? I guess I'm not sure.
So Marty, if you are still here, can you please unmute yourself? Yeah, Marty is still here. Can you please unmute yourself and please elaborate?
Hi, the question actually is there any reason that you should not start putting lactic acid when you're starting the fermentation? In other words, give it a head start instead of starting out with just basic stuff. Put in a little lactic acid or lactate in order to jumpstart the process.
Yeah, some people do that. Some people will put whey in kind of as a starter. You know, if you've kind of grown your own vegetables, chances are, and you've grown them organically, chances are you wouldn't need to do that. That lactic acid is on the vegetables, and to have it start naturally, you know, you can see that at the beginning of that one graph. You know, if you do that, it lets let me see if I can page up. I'm locked up here, but you know, there's a bacteria that begins the fermentation, so it's nice to let it do that. But if you have a fermentation, especially that's stuck, or you just don't seem to have any luck with it going, yeah, you can add a starter. That's fine.
Thank you. And the most important question: where can we get your product? For Sharon, well, Miss Sharon here.
You can come to the Brookside Farmers Market tomorrow. Look it up, brooksidefarmersmarket.com. We're down at Billy's Grocery now. We're at Green Acres Market in Briarcliff. We are out at Colonial Gardens. We're part of Chateau's Delivery, Herbivores CSA, and their farm kind of stand that they have. They have our ferments. So that kind of the 4 points around the city. So yeah, and we're hoping to have a few more spots in the near future.
And I have a question. Actually, I included like a link here to when I tried to do cucumbers. This turned out pretty good. And one time I had a problem with a kind of a grayish mold because I didn't have it covered all the way. So I threw it away. And as I said, my house is way too warm. I remember, you know, when I was growing up, we kind of did it in the basement. And I guess I don't have a cool basement here in the United States. And also, somebody asked if you are C3 organization. I guess not for I don't know, what is it? Not for profit, I guess.
Oh, 501c3? No.
Yeah.
Nope. We're a for-profit farm.
Okay, yeah, but I don't know why they asked, but that was the question, so I'm answering. So, well, thank you very much, Tom. Thank you everyone for participating. This is our regular Lunch and Learn for a kind of wellness series we started during COVID over Zoom. So check our website, because when we have a permission of the presenter, we record our sessions. And also we have Healthy Living Book Club, and we have more wellness series coming next month and in the future. So please check our calendar. Thank you so much, Tom. Thank you for doing this for us.